So thank you so much for listening to our talk today. We're here to talk to you about enabling faster delivery with collaborative platform teams. My name is Leoren and Tesaluna, and I am a senior platform engineer at OnePass under OneDigital. Previous to that, I have worked in a variety of central platform teams across different tech companies such as RA Group, MYOB, and Australia Post. My LinkedIn handle is up there on the slides if you would like to connect with me or if you have any questions for me after the talk. And with me is Justin.
Hey everyone, my name's Justin. I'm also a platform engineer at OneDigital under OnePass division. In the past, I've worked in a variety of roles. I've worked as a software developer at NAB. I've worked in private cloud deployments and integration at Ericsson. And I've worked in AWS DevOps at OpenPay. And my LinkedIn as well is just on the screen there. It's just my name, Justin Bugeja. Back to you, Lauren.
Thank you, Justin. So let's talk platform. If you work with, oh, sorry, before that, let me quickly introduce ourselves again. As me and Justin mentioned, we are a part of the Wesfarmers group, which is the home of OnePass. For those of you who are not familiar with Wesfarmers, hopefully you are familiar with some of these brands. So Kmart, Catch of the Day, Target, Bunnings Warehouse, and Officeworks are all part of the Wesfarmers group. And OnePass, which is actually part of OneDigital, is its newest recruit, established just in 2022. OneDigital's purpose is to power Wesfarmers' digital and data growth ambitions across its retail businesses, and OnePass is a subscription program that provides members with perks, benefits, and convenience when shopping in the group's retail business. Now let's talk platform. So if you work with platform or DevOps teams within your organization, or if you're still in the process of trying to create or establish an internal platform within your organizations, hopefully you should be able to take a thing or two in this talk. Now, in every company, development teams need infrastructure and tooling to be built. In today's technology, most infrastructure and tooling are now starting to get built in the cloud. Development teams need to be able to build their applications that are designed to run in the cloud and also take advantage of all the services that the cloud provides. But the cloud is ever changing. Teams need to be able to embrace new services that are emerging. Teams need to be able to create their applications on services that are secure, reliable, and follows company compliance policies. So who's going to build these services, right? Well, one pattern that seems to be becoming a very common pattern in the industry is that it is the platform team's responsibility to create all infrastructure and tooling for them. So the developers are the platform team's main customers, and it is the platform team's responsibility to create and manage all infrastructure and tooling for them. Well, as some of you will quickly discover, this way of working usually becomes a problem. You know, Justin and I, we've been in many places where the platform teams are siloed and there isn't much communication happening between the platform teams and the delivery teams. This causes a lot of misunderstanding as there is so much abstraction and magic happening within the infrastructure and tooling. The platform team also tends to become a bottleneck, a blocker for all of the features and the bug fixes that the developers want released. And as we all know, when a team becomes a bottleneck, a blocker, this results in a lot of time wasted waiting, which I'm sure a lot of our engineers and leads here are probably not going to be a very big fan of. Now, in order to fix this, we need to find a way so that the platform team is not the only team responsible in creating and maintaining all the infrastructure and tooling within the organization. Rather, we want the platform team to be enablers. We want to be able to get help from our developers in managing and maintaining this infrastructure and tooling, and for the platform team to enable them in doing so. One way you can do this is by training all of your developers to be an expert in the cloud computing space, like AWS. But that's pretty expensive, right? Because you'll find that you're not going to find many engineers with that much cognitive load to spare. They're already too busy. It's a bit unfair to add that extra context upon them. But you do have another option, and this is what worked for us in OneDigital. In OneDigital, what we've established is a partnership with our developers. We were able to create a model of open source tooling to manage our internal platforms. In this model, teams are able to unlock themselves. In this model, teams are able to get a good level of understanding of the underlying tech stack without needing to be an expert. And in this model, we were able to create a much happier and much more collaborative culture amongst our teams. So, how did we do it? Well, we started with actually communicating with our customers. So in this case, our developers. So we wanted to communicate with them to really understand what is it that we can build out for them. In OneDigital, what my delivery lead has done is that we actually set up a meeting with each and every team that the platform team look after. In these meetings, we sat with the teams and we asked them to explain to us their current tech stack, their current infrastructure. Now, this is a really cool challenge because it actually tests your team's knowledge around their underlying tech stack, kind of gives you a good gauge of how much support they'll be needing from the platform team. Anyway, in these meetings, we were able to create a table that looks similar to this. So as you can see here, the first column are different teams within the organization. The second column are some information on the resources that they use within those teams. And the last column are some comments around their deployment strategy. Anyway, in this table, we were able to identify that there's actually multiple teams using the S3 bucket resource. But as you can see in the comments, deployed using different ways. We were also able to identify some teams using the ECS, Lambda, and SQS resource. We also saw some potential improvements on teams deploying manually. We started thinking, can we automate this? And then with this, we started having a little bit of an idea. What is it that we can do for our teams? Is there anything that we can do to provide some consistency around the way that our teams deploy? And so after this, we went away having a bit of an understanding of what is it that we needed to build first. So what did we try first? Well, we created patterns. So we created patterns around those common resources that we saw that our development teams were using. So again, the goal of this was to provide some kind of consistency around the way our developers deploy, but also to reduce some cognitive load on those development teams that are deploying the exact same thing. Now, what the platform team has done in my previous organization around common patterns is that we actually created a bunch of CloudFormation templates around those common resources that we saw our developers were deploying. Along with this, we also provided a deployment script that allows them to easily deploy this in their AWS applications. When we created these CloudFormation templates, we also ensured that they are built with security, basic security implementations, they are built with reliability in mind, and they are also following any company compliance policy so that our developers don't need to think about those. Anyway, so if our development teams wishes to deploy a resource within their AWS account, all they have to do is in their GitLab pipeline, they have to include this, they have to add this include statement in their YAML file. For example, here an S3 resource. And when their pipeline runs, it automatically deploys a secure reliable and compliant S3 bucket for them in their AWS account. So this is quite easy, right? Quite neat, quite nice, very, everything's done for the developers. So what did you think went wrong? Well, in that pattern, the platform team is actually managing all of those CloudFormation templates in a repository where the development teams don't really have much access to. So the templates are kind of abstracted. So when the developers deploy puts that include statement on their pipeline, they kind of don't really know what's going on under the hood as we're abstracting all of those templates away from them. Another thing is that even if we do end up opening up those repositories where those templates are saved to the developers, CloudFormation is not really a language that our developers were quite familiar with. So they have trouble understanding what's going on under the hood anyway, and let alone, try to collaborate to it. Now, we did some pretty similar things in OneDigital, which I will now let Justin walk you through.
Thank you for that, Leoren. So just to give a bit of context, over at OneDigital, we're a platform team of about 7 engineers, and we support about 7 delivery squads. So 1 engineer per delivery squad, it's enough to communicate with them and have a show of presence, but it's not really enough to understand every solution that every squad is using day in, day out. In the beginning of OneDigital, we used Terraform for all of our infrastructure as code. Terraform is written in HCL, and it's a declarative language similar to how CloudFormation is written. It's not written in a programmatic way. And we chose this language because we had a lot of, contractors who are experts in Terraform, and that's what they wanted to build everything out in. And Terraform is very widely used in the industry, but for us, we had a few problems. Similar to what Leoren was saying with CloudFormation, because it's written in a declarative way, it is unfamiliar to developers, and it's something new they have to learn, which wasn't easy for them, and they wanted something that they could pick up a bit quicker. What we decided to do as part of the platform team was move towards using AWS CDK, Cloud Development Kit. Cloud Development Kit is also a way of provisioning infrastructure as code, but instead of being written declaratively, it's written programmatically. So you can choose from about, 5 or 6 different programming languages to choose from. There's TypeScript, Python, JavaScript, a bunch of different things. But what we chose was TypeScript for our CDK projects. The reason being is all of our developers are using TypeScript in their day-to-day work, and we thought this would be easier for them to pick up and understand. As a platform team, we'd probably choose something more familiar to us, like Python, but we decided to try learn TypeScript and pick it up for the benefit of our developers. In CDK, there's a thing called a construct, and this is basically a building block in CDK. Almost anything can be referred to in terms of a construct. There's a lot of other different things you can do in CDK, but for the purpose of this presentation, I'll focus on a construct. You can think of it as a building block. So let's say you've got a S3 bucket, but with that S3 bucket, your company policy requires you to have that encrypted in a specific way. It might also require lifecycle policies, so older objects can get moved to a cheaper storage class. You might also be required to have IAM policies on that bucket, so the right people have the right access. And you might also require tagging on that bucket. Now, what a construct can do in CDK is wrap that up and give that as a building block for a developer to deploy. They can deploy their S3 bucket and not have to worry about all these bits and pieces that your company policy requires. And we thought this would be awesome. It'd be great for the developers to use. easy for them to deploy. They don't have to worry about anything, right? It has a lot of benefits, reduces duplication of code, so you don't have to write the same thing multiple times. Reduces cognitive load, so the developers don't have to worry about encryption and bucket policies and that sort of stuff. It's more sustainable support model for the platform team, us. We know what's being deployed and we can support that. And it's more standardized tooling. So if everyone's using CDK, we know what language we're supporting and what frameworks we're supporting. And yeah, we thought developers would love this. Developing in TypeScript, using their own language. We thought they'd look a little like this guy. Instead, when we spoke to the developers and saw how they felt about our constructs, they're a little bit more like this lady. The people that were using our constructs had a lot of trouble with it, and the majority weren't even using what we had built anyway. So what happened? What went wrong? We thought we were doing a good thing here. Turns out, after speaking to the developers, we had a bit too much abstraction. So by trying to hide away all this encryption and bucket policies and bits and pieces that our company policy requires, we were hiding it away where the developers couldn't see it. So when they had to deploy something, they didn't actually know what exactly was being deployed. And when they had an issue deploying something, they had to come to the platform team to help them out. They couldn't look at it themselves. There was also another issue where we had a bit too few constructs. So because we chose TypeScript as a language that we weren't familiar with as platform engineers, there was only a couple of us who were able to build these constructs for the developers. And we needed more people contributing to this. Just the platform team wasn't enough to support all of the different delivery squads. We were hoping maybe the developers could help contribute. It was at this point we kind of reflected and found that we were still a bottleneck, and there was something we had to change. We reflected and found that we had these points that we had to build our product by. We had to be more transparent about what we were building. We had to remove those complicated abstractions and make it more visible to the developers. We had to stop gatekeeping our product. We had to let other people contribute to it. And we did this by opening up our GitHub access and not restricting other teams from helping us out. These points formed the basis for a product which we called CloudKit. CloudKit is built upon the CDK framework. It's built in TypeScript as a language, and it's a product that is maintained by the platform team, but is co-owned by everyone in OneDigital. So no one is restricted from making a PR or making a change on CloudKit if they wanted to. But just creating this product wasn't enough. We had to have some way to get the developers involved and contributing to CloudKit. And we found out that we kind of needed to change the culture, not just the tooling. It was at this point where we wanted to adopt an inner sourcing culture. Now, if you're not familiar with what inner sourcing is, it's basically the act of taking open source methodologies and applying it to a organizational or private project or product. If you want to learn more about inner sourcing, there's a great website called Inner Source Commons, and they've got this book called Adopting Inner Source, which is provided free courtesy of PayPal. There's a QR code on the website on the screen there if you want to take a screenshot. But highly recommend this book. It's very, very insightful. I've just taken this quote from that book. And this quote really resonated with me, especially those two words that I've highlighted in green. Because at OneDigital, what we wanted to do was leverage and empower our developers to contribute to CloudKit. To do this, we had to build a community of trusted committers. This is another concept from Adopting Inner Source. And trusted committers are basically people who are experts in a product. They know how to contribute to it, and they can help others to contribute to this product. And we thought this would be very crucial in getting more people involved in CloudKit. But to build this community, we had to start small. Initially, it was just the platform team who were trusted committers, and we had hopes to grow out from that. But in growing out, we had to make sure we grew organically. We didn't want to tie in a bunch of policies and force people to contribute to CloudKit, because forcing them to contribute to it wouldn't really make them want to if it's not part of their day-to-day work. Key to doing this was communicating and collaborating with our developers. And we had many different forms for communication. One of these are communities of practice. You might call them guilds. These are smaller communities where you can gain interest in a product or feature that you're thinking about creating and seeing if there's any interest in the community. We have engineering huddles, which are more engineering wide, and you can show off a product that is about to be released and see if there's any feedback that you can get from it. We also have showcases, which are company-wide, and it's more for showing off a product that's out in the wild and seeing if you can get more users onto it. But key to collaborating as well was pairing with those early adopters. These are the people who are keen to get on a product in its early stages, and they're not fussed if everything's not working very smoothly. They can help a lot to really guide the direction of where your product will go. One example of this was when we worked on an S3 static website pattern. This was a pretty basic static website using an S3 bucket and CloudFront, but we had a somewhat complicated authentication mechanism at the front of it. All of this is a pretty big piece of work for one engineer to take on. So what we decided to do was split it up between the platform team and the developers. Myself, as part of the platform team, worked on the authentication pattern, something a developer doesn't really need to worry about, doesn't affect the app in any way, and it's more of a platform duty. While we gave these constructs to the developers to work on. So that's the S3 bucket, CloudFront, and KMS. In creating these patterns, they get exposure to CloudKit, and they also get experience working with a static website. So it's very useful. In parallel, we decided to work together on the authentication and constructs and make sure to communicate throughout the entire process. In the end, we got a pattern out and working, and we gained interest from other teams who were wanting to use it as well. It was at this point where we were doing pretty well with our journey. We had got developers using CloudKit and contributing to it, and started to get interest from other teams as well. But we didn't want to just stop here. We wanted to keep the success going. I'll let Leoren explain how we did that.
Yeah, thank you for that, Justin. So there's definitely a couple of things that we needed to keep doing to keep our engagement going. And here are just some of the things that we created with our developers together. So the first one is actually around documentation. So again, we went back to our developers and we asked them, how would you like your documentation maintained? And it turns out a lot of them prefer for the documentation to sit within their code. So this was a really cool tool that we found online. It's called TypeDoc. It's open source, and it works really well with TypeScript. Essentially, what you have to do is you put your documentation as inline comments within your CDK construct. And when your pipeline runs, it creates this beautiful documentation automatically for you that resides within your repository. Another thing that we like to keep doing, or our developers appreciate doing, is to keep embedding processes upon our contributors. So this is a pull request template that we created for our internal tooling. And essentially what it does is every time you raise a change against our internal tooling, it presents you with this list of things that you have to ensure to do. So this helps embedding some processes to our developers or contributors to ensure that they keep doing the following items. So things like, ensure you update any documentation related to your change and provide us with any tests that you've done before even raising this change. So this was a really cool practice that we've adopted. Another thing that we really like to keep doing is to keep our developers involved and updated with our internal platform and tooling. So in OneDigital, we have this thing called an engineering decision register, which is essentially a space where anyone can raise any decisions that needs to be made within our internal platforms. And every engineering huddles or every engineering lead forums, which often happens every fortnight or every week, we raise any decisions that are still open that we need to make, and together with the team, we come up with a outcome together. So as you can see there on the slide is an example of a table of some of the decisions that we had to make, and it shows you the status, who raised it, and what was the outcome. Aside from documentation, we also provide some training. So we do knowledge sharing a lot, and we record them to share to other people exactly how to use and manage our products. We sometimes temporarily embed a platform engineer in a delivery team to teach them just exactly how to adopt and collaborate to our products. And we also provide boot camps for CloudKit to teach people exactly how to use CloudKit. Aside from boot camps, we also provide some self-paced training materials or labs that our engineers can tackle in their own time. And along with this, we provide a little helper Slack channel where they can ask us any questions in case they get stuck or they needed to clarify anything in the lab. But of course, aside from documentation and training, we always ensure to celebrate. So in OneDigital, every time somebody adopts to using our product or every time somebody contributes to our product, we give them a little shout out on Slack. So this really helps encourage other engineers and other developers to do the exact same thing, collaborate, adopt, and work with us. And with this, we were able to create a much more happier and much more collaborative culture amongst our teams. So anyway, we've talked a lot, but just to recap with you, everything that we've done in OneDigital to get this going. So the first thing is that we communicated with our customers. We tried to find out exactly what is it that we needed to do for them. We were transparent. We opened up our repositories, allowed people to contribute to it. We also started the culture of inner sourcing, and we kept our engagement going by keeping our documentations up to date, providing trainings, and celebrating. Now, Justin will walk you through how you can get started.
Thanks, Leoren. So, how can you get started? If you're a developer, try to engage more with your platform team. See if there's any issues that you're facing that they can help out with. If you're part of a platform team, look for patterns in issues that your developers are facing. See if you can create maybe a product that can help them in many ways and help many teams at the same time. If you're part of delivery or project management, maybe consider trying to adopt an inner sourcing culture within your community or within your company. But throughout our journey, we've learned that platform products need to be built collaboratively and with your customer, the developer, in mind. And I just want to leave you with this one quote, hopefully something you can walk away with. And it's that platform teams should not be gatekeepers, but rather enablers. Thank you for listening. That concludes our talk.
Thank you, everybody.